Welcome back, everyone. Today we are going to take a look at molar mass and its progression to grams to moles and moles to grams. So for this section of instruction, you're going to need a periodic table, and you'll also need a calculator if you so choose. All right, so first we're going to take a look at the molar mass. The molar mass is just everything within a particular compound or element in question, and you're wanting to determine how much the entire compound weighs. So one of the first things that we're going to do is we're going to determine the molar mass of a particular compound. So the compound we want to find the molar mass for is going to be all right. So we have CCl2, F2. Okay? So take a moment and reference your periodic table and find those particular elements and note their atomic mass according to your periodic table. All right. So here we're going to go ahead and do what I call make a shopping list. Okay. So we know that we have a carbon, we have a chlorine, and we have fluorine. But we need to go back not only and notice which elements we have, but how many of each element. So we have one carbon, we have two chlorines, and we have two fluorines. According to the periodic table that I am using, carbon has an atomic mass of 12.01 grams per mole of carbon. Chlorine has an atomic mass of 35.45 grams per mole. And then we get down to fluorine. And typically we know in nursing we lead with zeros and never follow. But for the purposes of this, we will. All right. So now what is necessary to be done is to go ahead and multiply each of these numbers of atoms of these individual elements to obtain how much their portion of the whole compound is. So one carbon times 12.01 is going to give us 12.01 grams per mole. We have two chlorines, and that's going to work out to 70.9 grams per mole. And then our last and final compound is going to come out to be 38 grams per mole. And molar mass is just as simple as taking all 3, 4, 5, however many elements in your compound and adding them up. And if we were to add all of these up, we would say that we have 120.91 grams per mole of CCl2F2. All right. So now that we have the molar mass, we're going to step out now and attempt to say or solve a problem that is asking us to convert from grams to moles and moles to grams. Okay, our school uses dimensional analysis to solve such problems. So let's say we're going to use the compound we have here. So it's asking us to take grams and convert it to moles. So let's say I have 75 grams of CCl2F2. F2, I need to find out how many moles. Okay? And in order to do that, dimensional analysis allows us to set our problems up in terms of what we need in reference to what we know and what we have. So we'll first start within the far left. We're going to write moles. Okay. Dimensional analysis, we know that we are able, no matter what, it used the communicative properties of mathematics, that as long as the two terms that are married or coupled together stay together, it doesn't matter which is in the top of our ratio and which is in the bottom. So whatever unit is here, and the singular of that is going to be mole. Look back at your notes. Look back at your problem and see, where do you have a number of moles? Here we have the problem has supplied us with a mass, but we're searching for mole. So this is when we would reference or find the molar mass of the compound in question. So here we would say that 1 mole of that compound is going to be married to 120.91 grams. In dimensional analysis, no matter what this unit is here, we know it has to go on that line right next to it. So now we can go back and search our problem or the notes we've taken from our problem and find the unit and the number assigned to it. So in this problem, we were given 75 grams. So that is where we can fill that in. He is not married to any other numbers, so we would place him over 1. Now, we go ahead and cross out like terms. We have 75 over 120.91. We're going to plug that into our trusty calculator. And for all of the mathematics in chemistry, I have found something as simple as this $1 calculator is just enough to do what you need to in your chemistry courses. So if we divide 75 by 120.91, we are left with 0.62026 mole of CCl2F2. Always remember to round your answers to the appropriate place that is either placed in your instructions or in your questions. So in this case, we'll round this one to the nearest hundredths place. So that will be rounding it here. We look to the number right next to it and see if it's more or less than 5. 0 is less than 5, so we would round this to 0.62 moles. Okay? Now let's take this same compound and go from moles to grams. So let's say we had 2.5 moles of CCl2F2. How many grams do we have? Just like before, whatever we're solving for goes to the left. We are solving for grams in this case. So grams is what's on the left of my page. Whatever unit is there is going to be the first unit on my first line. And where will I obtain this gram? Well, this is actually going to come once again from the ratio of grams to moles. So we know that we have 120.91 grams is married to 1 mole. Remember, all of those items that are coupled together must stay together. Then we come here without even knowing what numbers. We know the unit is going to be whatever unit is on the bottom. Reference your problem or your notes. And here we'll see we've already used our molar mass. So remember, in grams to moles and moles to grams, the first thing you're going to place in that problem is going to be your molar ratio or your molar mass, because it's going to be based on your entire weight of your compound. So here we have our 2.5 moles. It is not married to any other item there, so it's over 1. Once again, we go through the process of crossing out like terms because we know we're at the end because we've used all of the information supplied in our instructions or in our problem. So now we're going to take and multiply across the top. So 120.91 times 2.5 gives us 302.275. Do not forget to multiply across the bottom. It gets you in good practice because as you saw in the first problem, it did render a number in the bottom. So 1 times 1 is 1. 302.275. And let's go ahead and round that to the nearest whole number. And if we were to do that, we look to the number in the tenths place. If it's less than 5, we round down. If it's more than 5, we round up. So we have a 2. So we're going to be rounding that down. And we have 302 grams of CCl2F2. So that is our final answer for our moles to grams problem for that particular compound. All right. I wish you all happy studying, and I hope this was helpful.